Hello, everyone, and welcome to the broadcast. We are back again. We're going to be picking back up with our game dev project. I've been wanting to get that coding going. Let's see, Iden is joining us. I do have the tall format going again. Keats and James, we're all here. Welcome, everyone. Let's check in with Kitties first here. So Sky's up in his tree doing his little foot off the side thing. Tom used to do that too, but he would actually, it would look much more like arm out the window kind of thing when he was doing it. Ember is on the bed. Now I rotated the bed camera around a little bit, so we should be able to see more of them. Often, Sherbet would be a bit above where Ember is right now. Slightly out of view. Sometimes Sammy would be in that spot. We'll have to adjust the lighting because it's a little stark from that position. Now Sherbet is in the little box in the play area. You can see there's lots of places they can lay. The air hockey table is primarily for Mason. I'll often go over there and play with him by knocking the pucks around. He'll lay down and want to be pet, and we'll grab at the little air hockey pucks. And every now and then when he's bored, he'll play with them himself and usually run off with one of them or so. But yeah, we're getting back into the game dev project. Last time we started to get a sort of pseudo dependency injection going, since the special format as far as like a web app for C# could still work here, but it could be a bit fiddly to get everything together, since it wants to instantiate classes, and some of the things that we've got are packed scenes and need to be treated as such. Like they are a node in Godot. But looking at it, I don't know if the full dependency injection model is viable for us. Because, let's switch over to the screen here. Of things like this, let me show you. In behavior, when we initialize it, we are passing in the catalog and the entity manager, and I don't like kind of how far in we'll go. There we go. But let's see here. So I'm passing in catalog and entity manager all the way down in behavior, which means the catalog has to be the one that creates the entity manager, which this is just so circuitous. Now, for some of the objects, I think it's fine for us to be passing these around. Like as a lump kind of thing. So every object could be given a lump of active services, since all of the services are largely game instance dependent. But things like the catalog would be created outside of the game world. So that could always be present. And we wouldn't have to worry about constructing it that way. Each time the game would be instantiated, we'd create a new, like, active services lump, or container class, I think would be more accurate, and pass that along. Then we don't have to be How have I been, Keats? Well, we had a bit of a protracted break. Things weren't going great over here at the factory, so we had to delay for a little bit. But we're back at it. We're back at it. We got to play some games recently. I don't know if you saw those. Did a couple of creepy games. Those are always fun. Had to play some more observation duty. And we got to try the Monster Hunter Wilds beta, which was a lot of fun. I think the hype on that is well deserved at this point. Game was, even during the network beta, pretty stable. And we got to see a lot of the cool stuff that's going to be in it. There are probably some numbers that they'll need to tweak, but nothing like game breaking was visible. But to my point, I don't want to have to pass in things like entity manager and catalog all the way down to the behavior level. Specifically, I don't want to pass them down. It's fine. I did this twice. Like, it's okay for it to need these. Behaviors have access to them because, or take access to them in case they need to create other things. So if, say, a behavior wanted to change into a different one or add a different one to the existing object, or say spawn another entity or similar, it would need access to the catalog to define it. But that means we have to get the catalog to it, and currently that's this daisy chain of initialize functions. So instead of that, having the core create those, and I think well, we've been doing the coding very differently. I don't know if you were there when we switched over to C#. I don't recall. But we have substantially changed the whole architecture. And hey there, Sasha. Welcome. For those that aren't aware, I do have the tall format running again. I feel like this is just going to be our stream time going forward, and that means I have more flexibility as far as just using the tall format. It is a bandwidth intensive, and earlier in the day I don't have the option of being that bandwidth intensive. Okay. So to get things like the catalog and the entity manager primed, we're going to have to set more of that up early. So I think we want we could have everything do that. Okay. So if we look at our game object, there it is. The project tree is getting complex. So we have our camera. Sometimes that's going to be needed. Entity manager, catalog. These are critical aspects right now for the game. But if we look, the catalog and the entity manager are set up right away with the game. Then we're going to set up, like, we can see all of these things getting primed and then passed around here. Wow, YouTube chat's being flaky. Very flaky. Check a couple of things there. Okay. So the game goes in and it initializes all of this stuff. It says, here's a catalog, here's the collision manager, here's inventory, here's render, and then it adds child nodes for all of this stuff. The catalog does not need to be a child of the game. The catalog should not change or be recreated each time the game starts. That's entirely wasteful, and it would be even more so if I ever get around to making the catalog like an external script kind of thing, which I would want to for mod purposes down the road. Like, that feels like a good pattern to have ready, both for updates, so I don't have to go into a protracted blob of code to get all of these things. I could just specify this class, that kind of thing. That's I'm gonna say Cosmo. You got curly Q writing there in the name. For tracking, I use two different. So of course, VTube Studio. But then for the actual tracking, I've got my phone set up to be the camera, and then I use a piece of software called Vitamins. I primarily use Vitamins because it gives me very minute control over some things. Some software has problems tracking my eyes because, glasses, that kind of thing. Mouth movements as well. So I have script in there. It's kind of like a little JavaScript style language. It might even be just JavaScript. But anyway, it's a scripting language that lets you edit the way that the inputs are interpreted. So I use that as the intermediary. It connects to the phone, it connects to the camera, and then it passes the stuff along to VTube Studio. Okay. So if instead, since there will only ever be one collision manager, one renderer, actually, let me check my collision manager code. I am having to remind myself we've had a little bit of a gap since the last code stream, so I've lost track of a couple of things. Okay, yeah, we have different collision areas in the manager. So there's one manager, one renderer, that kind of thing. So for the purposes of the game, it has an entity manager, but which is created each time. But that doesn't need to be created in the game object. Could still be. Catalog could still use a wrapper object so it can all be passed in. I don't like that the catalog needs to talk to Entity Manager. I definitely don't like that. Because that means that the catalog can't be a local object. It needs to be, like, the Entity Manager that it has would need to be refreshed each time. A lot of this is circling back around to the idea that there is a singleton floating around that is references to those classes, which has some aspect of danger to it because interacting with an object that has been freed from a tree um, can result in some bad stuff, which means I need to have careful cleanup logic when the game object is removed in order to pull all of the elements out of the singleton. We could have it where each time these objects are created, so when I instantiate this is by nature going to create a new class. Once that's done, within it, it could pass into the singleton, hey, I am the current one because I have been created. And then when it's removed, it would null that value and say, there is no current one because I am gone. There is a risk surface with that, but since these are like master services, I think that could still work. I'm calling them services. We're sort of doing a little song and dance around dependency injection in this. Because again, standard dependency injection won't necessarily work for us terribly well, because we need Godot scene objects available to us. Some of them less so, some of them more so. So like an inventory UI needs to be a scene. No matter what it needs, like a catalog to look up things like textures, it needs to be a scene, which means registering it as an object to create would be fiddly. We would need to constantly register it as this is the thing. Like, this one is the instance. Because we would never new it. We would use the Godot instantiate. So, I think in that vein, there should be a singleton that manages this stuff. Okay. So we could have a refresh and rebuild kind of thing, where within the code logic, it knows the sequence to go through. That is, it's only going to ever create the catalog once, and then all of the subsequent objects get loaded into the singleton as needed. Yeah. So we have entities, we have collisions, we have our catalog, HUD, inventory, rendering. All of these are part of the game object. So our startup resource is the thing that tells us what to use, the packed scenes that we're going to implement. Okay. Because it can be a global static. It doesn't actually have to be a Godot constant, which is good. Godot constant collections are actually just nodes, like global objects, whereas what we want is a static class in this case. Kind of what the Godot one was anyway. We're going to call you. Okay, so we're using Godot just in case. We may or may not need some of these other things. We'll get there. So we have a... So we have our catalog object. We're going to have entity manager. I do get kind of locked in while I'm coding, but feel free to chat even if it's not about the coding. This is... we code and we chatter at the same time. Let's look at our game object here just to be sure. Catalog entity manager, our renderer, our collision manager. Inventory, we're potentially going to change around entirely in this. Inventory is entirely part of the player state. So that's going to include all kinds of other aspects that will be handled within the player object. We don't have the full concept yet, but there will be an idea of within an entity, hey, you got a message. And for the player, that's going to be like one handler. Hey, a collision happened. You received damage. The player one will be a universal handler for that. So we're going to end up swapping out inventory here for something else. YouTube chat is having problems. I don't know why. But it is. So forgive me if some messages don't come through on the YouTube side, folks. Clearly there's something going wrong here. Check my feed here. Yeah. Something going on. Something going on. So this will be player state. We're going to get these other ones in place first. Because I would also like to minimize the amount that the startup resource is referenced elsewhere. It will need to be. For things like the player inventory UI needs to be set up like that. So we'll have to see. We'll have to see. So catalog entity manager, a renderer, a collision manager. Okay. Control. Okay, So some things will need this in order to get the packed scene that they will use. So if we look at the inventory here, standard inventory. Initialize. Right. So here we talk to the startup UI, the startup resource to get an inventory UI. By making it so that there is a player state, a higher, a service level player state, we can have the game use the inventory UI as a separate thing. Like that can be a entity that is handled outside of the actual inventory, and it doesn't need to be part of the inventory object anymore, because it can just reference the player state from the singleton. Again, getting it from the equivalent of a dependency injection service where we say, or host or whatever it's called, where we say, okay, at the time of game start, we already have catalog, let's keep catalog, but let's go in and instantiate all of these other objects and essentially overwrite the existing settings. Yeah. So, in our services object. Hey there, Blocker. Welcome. We're working on our code. We're setting up a kind of a services container so that we can do a kind of dodge around Godot. We're instantiating dependency injection into Godot to work around the limitations of interacting with UI scenes and nodes. Fingered a couple of things there. All right. Okay, so this is where we're going to use startup resource. Okay, we need to do an initialization on it and give it startup resource. Void initialize. That will take a startup resource. So we store this off, and now we're going to instantiate the catalog using startup resource here. So if we look at our existing game here, we're going to do this. So we are creating a node here, and we're setting it. This node can subsequently be used elsewhere. It doesn't actually have to be a node anymore, but it is for the purposes of our interaction here. We can set it as a child node of the... We can set it as a child node of the game, but instead we're probably going to set it as a child node of the core. Because it will always be here. So then the rest of them, Entity Manager, Renderer, Collision Manager, all of these things are going to be created here as well. So right now we're initializing them. And this is something that I don't want to have to do. We will add this child in our game object when, within the core, where we load it up. We get our standard, our startup resource, and we load it up there. Subsequent objects will have access to all of these up until a new game object is created. Yeah. There's going to be a substantial rewrite going on here. Well, a hassle of a rewrite. So we're going to need to go into all of the parent classes for these things and scrub them down here. Services, and it won't be render, it will be renderer. Okay, we've got each of these primed. And if I do this right, they won't need these sub-instantiations. For the time being, let's actually put an inventory here. I will want to change that, but services. How strange. Huh. I wonder why. But hello, lore. How has that, I don't even know what it was called, like the Hero Factory thing? How has that been going? Parakeet, that is kind of the coder state of being, outside of somebody cracking the whip on you from a corporate perspective or something, is, but what if I refactored again, you know? The real test with an early access game like that, lore, is if the developer is paying attention to feedback on how some of those things work. Let alone if they have telemetry built into it. I really think if I could safely set it up, having something that takes logs and sends them, like, was this used kind of thing? How often is it used and what does that lead to kind of stuff? Hello, Sherbet. Still trying to figure out what is... Sherbet and Ember are both prone to acne. They get a lot of blackheads on their chin. There's really two ways that kind of thing can manifest with cats. The horrible pimple style, kind of what people would be familiar with. Which cats have thin skin, and it's not like those pores are going to be treated any different by the relevant bacteria. You can get that. Tom had that. It was really gross to deal with. Sky had a very small amount of that, but he's not really prone to it. Ember and Sherbet have the other form where it's almost like it seems like a scab initially, but it's kind of like a crusting that runs up the fur on their chin. And you have to slowly kind of break it apart and get it loose. Ember really, really doesn't like it, and Sherbet doesn't like being held down in any way. Though Sherbet is easier to handle once you've got him scruffed. It doesn't work on Ember. She fights the whole time. Okay, so we've got these objects set up. Now we're going to call in and we're going to initialize them, but I don't actually need those values there anymore. We've got them in the static. So let's go piece by piece here. We're going to go into our catalog first. And we're going to pull the initialize call out. So first we need the base catalog. Its initialize is not going to take anything. In fact, it doesn't need to be there. That is going to have a ripple effect down into the rest of it, which we're going to get to after a quick break. one of the times we're going to figure out this Twitch advertising thing. Such hassle. Okay. So we remove the standard catalog initialize here. And instead, we can get that right in the constructor. So let's see here. It doesn't need to know Entity Manager. Catalog is a primal object. It just needs to be created first. Okay. That's why. It's a standard catalog. All of this stuff to be set up. And we're going to remove this behavior's initialize. Checking all of the places that might have lingering references to this. I'm not seeing anything obvious. Okay. So then let's go into not going to initialize any of these with a entity manager or a catalog. They can get it. This also removes an error surface in that, well, it narrows it down to essentially a couple of spots. Is the core needs to prime the static object as quick as possible, which will happen pretty much in the main of it. Then, before we instantiate a game object, we need to recreate all of the game-related services at that moment. It's going to be very handy ultimately. Okay, so there's the catalog. Let's look at the collision manager here. remove this initialize function. Standard collision manager. Right there. Right above what we are dealing with. This will be services.catalog. Services, entity manager, go. Do not call initialize anymore. Or calls to initialize. Okay, good. It's our catalog. Now let's look at our renderer, which has an initialize method, but not anymore. This is entirely an interface. This is startup resource. Calls to initialize. We need catalog in renderer in order to get the textures to render. We need entity manager to know when we are adding things. So that's our renderer. Ultimately, I may override, see if I can override the multi-mesh to only render when we tell it to, but we'll have to see. It's not really a big deal if we don't. It just means that the sprites keep animating. The inventory no longer has an initialize call. Instead, we're going to add all of this. The tail end of the constructor. Services catalog, services entity manager. Inventory UI does not initialize. Oh. Does not initialize with a catalog. Inventory UI needs the catalog because it uses it to get the inventory sprites. Just put this here. So we do this in an initialize call because we need to know how big the inventory is. We might be able to make this some sort of static, but by tying this to the player inventory itself, that might help. Or it might be a little cleaner. Now, the change we intend to make would actually remove this. We would have a player state thing here where it would say, okay, based on how many rows and columns there are in the player state inventory. You might ultimately keep the inventory as a separate part of the player state. It just wouldn't be a node 2D, you know? Okay, then the game object. Startup resource is equal to services.startup resource. So we don't need to initialize anymore. Services. Only need the render reference for this moment. Logged. These don't initialize anymore. We don't need to add the catalog as a child here. This would technically create an orphaned node at the very end of the program, which I'm not terribly concerned about. Does this thing even need these? It keeps the entity manager and the catalog entirely to do this and this. So I think it's okay that we keep a reference to it. these being part of the tree means that they'll be shut down accordingly. Okay. All right, what explodes? We instantiate it, we add it. Again? This way. Services, when we call initialize, that's when we set up the catalog. And then we have to prepare game services when we're going to instantiate a game. So core. Prepare game services. Hey there, Tass. Welcome. All right, behaviors have a lingering aspect here. Here we go, initialize. Entity. Not base. Variable. else? It's log is equal to services.catalog. Manager. There. Group calls base. Okay. So now behaviors have tasks we are working on. Oh, it's protected, not private. We're revising the sort of dependency injection that we did last time ish. What I was looking at the C# documentation on using actual dependency injection, but we can't really because of the nodes. Like, we might be able to get away with it by a whole lot of extra song and dance. Essentially, wrapper classes that instantiate the node inside of them, and then you pop the node out of it to use it. But, so instead what we've got is a singleton sitting outside of everything that the core handling will deal with, like purging and refreshing it. So when the core starts up, it passes in the startup resource to initialize it. That will create the catalog and all of that goodness. And then we're saying prepare the game services each time. And our little services here will go in and it will use the startup resources in order to create them. And then the game subsequently uses them, and all the child classes subsequently use them. No, it's not. Oh, standard. No. Ah, yeah, because we don't initialize them. Don't do that no more. Still in the middle of behavior. Doesn't do that. Will use its own. Catalog can't be null at this point. As soon as we've created the behavior, we have a catalog in the services here. Oh. No, we don't. Okay. Here. So this should create a catalog and get it loaded in. But the catalog needs a reference to itself in those services. So as soon as I create this, as soon as I do this, inside of it, it wants to set the catalog here. This will be a bit redundant. So what we're going to do is in the catalog, in fact, in all of these services, they could do this. Where as soon as they pop into existence, they set this. But how do we want to do? Because I can just call this and then set it. Want to do this. I think we could do this the other way around, is we can just instantiate one of these in the initialization, and they will set themselves up inside of this. Yeah, I kind of like that, actually. Okay. So let's go back through. So we're going to create a base method here. We want to do this. Kind of want this to actually be abstract, though. Okay, I think we can still do this. Yeah. Okay, and then in standard catalog, sing it. Let's see. There we go. Okay, so the catalog will define itself within the services when you instantiate it. All catalogs will do that. Okay. Then we'll do this for Entity Manager, Render, Collision, and Inventory. Isn't virtual, these need to actually be implemented. Okay. So then in our catalog, our services again, hello, Ember. Ember has come to sit with me. Yeah, there we go. So by rearranging the camera just a little bit there, we can see 3 of them fully visible. Amancio, yes, we are making a game. We're in the process of a bit of a refactor here. Just getting things lined up. Okay, so next is the renderer. We're going to call you an abstract class. Just because. this. Check the entity manager too. Constructor. Yes, Ember, I'm not paying sufficient attention to her, so she's crawling all over my face. Her little chin is all grubby again. There. Troublemaker. That's what you are. Okay, so the entity manager will set itself up in there. The renderer will set itself up. Collision manager needs to do the same thing. Hello. So originally Ember would just sit on my lap. Then she noticed that Mason would get hugs if he crawled up on my shoulder. Mason is big enough that he just kind of stands on my lap and puts his forelegs on my shoulder and kind of... He just kind of sits there and like, okay, now I get attention, right? Like, he's not really sure what he's accomplishing. Ember saw that and started to emulate it the same way that Sky saw Sherbet jump on my headrest and get attention. He will do that too now. They're learning. If you're new to the channel, I'm talking about my cats. I have 5 of them. 1 is on my shoulder, 3 are visible there. I don't know where the final one is. Let's check real quick. Activating cameras. 5th one's up in his cat tree. So you can see 4 of them. The 5th one is interfering with my ability to type. Start. To very carefully typing entirely with my left hand because the right hand has to constantly stroke Ember's back. There we go. Okay. Attention obtained. Okay, and then in the catalog. Let's prepare. Oh no, that's in services we do that. Okay, so collision manager is just this now. Render is just this. We need to address inventory as well. Ion inventory. Base there. Okay. Okay, and then we're going to jump into ready. Startup resource is null again. How is that null at this moment? Because we never save it. Startup resource. Yeah. We don't need to store off startup resource here. Because we have that in that collection there. We can still store it off, but now in Entity Manager, Snizzle, it's moving along. We're doing another bit of a refactor to handle pseudo dependency injection. We started down that road last time, and we're making some refinements to it because it was getting unwieldy really quick with these initialize calls. Okay, so in entity, someday, someday, we are going to have some testing in place. Well, that's the aspiration. And having this set up means I would be able to do some basic testing. You know, instantiate this, check, is it a thing? You know, are these here? Do they react properly? Oof. Not yet, not yet, Lunar, not yet. Maybe someday. Behavior group. Uh, and in behavior, virtual. Getting there, getting there. This behavior's null. we're debugging now. Is it, is the keyword for calling the parent? Because we don't want to actually... Oh, this is... By overriding this, this is the problem. We don't want to have to come up with a new name for this every time. Base. There. Oh, it's okay. Entity behaviors, not in behavior group. Initialize first, we call just in case we need to override initialize later. Yarn ball is not moving, but that's a start. Load entities. There we go. We are back to functional. Turned on a 3-shot spread, so it's firing faster. Then 3-shot spread in spiral. Turn off the spread. Move to cursor. Actually, this might be one with a... Oh, okay. This is just a break. So we do this? Start it again real quick here. So we add a break here. We add a move. This is a move to the right. But this is move random direction. It just spreads out. So they're moving random direction. We add a break in there, which will do nothing until we add this in. So they move a random direction for a bit, and then they start spiraling. YouTube chat is just dropping for me left and right. How strange. Okay. We are back to how we were. Let me get a quick commit in. Save the code there. Okay, we have that in place now. That covers the packaging. Now I think instead of just an inventory, a player state object. How do we cover that? Behaviors into items. Instantiate what the inventory UI will be. It's ready to roll as soon as we get to that point. I see we've got a raid there. Hello. From, let's see, is it Owl Kaline? Tricky, but welcome, Raiders. Welcome. We're working on our game yet. So, since we've got some new folks here. So the gimmick of this is we're trying to have like a Noida style system where you have little plugins. So the yarn balls move out in a random direction. I'm going to put this little mouse icon here. This is a placeholder. What this is doing is it's creating a gate. So now it's the yarn action is happening. And then after a short period of time, a secondary action can happen. So I'm going to take spiral motion here. So they move out in a random direction, and then after a wait, they start spiraling. These gates will not be standalone, but their presence causes this kind of behavior. They'll be grouped in with other things most of the time. we can have things like after the gate, it should split into 3 and then start spiraling. So let's show that with just the split into 3 after the wait. So a gate and then a split to 3. So you can see at about this point, they multiply greatly. This is what we're shooting for. We've been working on this for a while. This is our 89th stream of this. A lot of it has been performance improvement. We're using Godot. And we started with Godot's node structure using GDScript. And even with optimizations within GDScript, we were only able to hit about, let's be generous and say 3,000 objects. And as soon as you hit about that line, frames per second started to tank. So we switched over to C#. And now I think we can hit easily 8,000 at 60 frames a second, even with collision checking happening. So I think we've got it set up to stop at 8,000. It might go a little higher than that, but there we go. This is never supposed to happen, but that's the reason we're shooting it for such a high number. Is we don't ever want to reach the limit and have it stop spawning like this. If we take Vampire Survivors as a pattern, you can generally fit about 750 things on the screen tops as far as monsters. And then you account for some that are off screen. And then you account for projectiles, and being really generous, you could hit about 5,000 things, which gives us room for another 3,000 in the bank to use later. We don't have any sort of timeout behavior set, anything like that. So that's more to come. Today, we set up some effectively dependency injection with this object here, where we instantiate all of this stuff up front so that other things that need it can find it when they're initialized. We're doing that instead of actual dependency injection because some of these things, like how we're calling instantiate, these are not things that you can just have. You can't just new them. You have to call this through Godot to make them exist. Or else it's a big hassle. Because over on the Godot side, if we have anything visual like this container object, trying to create it at runtime is a huge burden. Comparatively, the code for it is fiddly, and so far it has never worked cleanly. But if I create those base objects on the scene when it gets instantiated, I don't have to worry about that. Some of the things, they don't have to be scenes, but by doing it this way, I can have, what's it hiding? Startup resource here, which is essentially a bundle of these scenes and shaders and whatnot that I can define in a object and then use that object as like a package. You can use a command line param to specify a different one of these to use, which could allow for things like runtime testing, where I can just set a different resource. Okay. So I was thinking of doing player state inventory, but it might be better to start down the road of interactions, let's call them. So right now, if a collision happens, I think it's an entity. Where did I put that? Right now, if a collision happens, okay, so we collide with another entity. If that happens, right now I've just hard-coded it. Instead, what we want is two different categories, potentially a couple of more. But we have, I collided with something. We're going to have messages that we send to that thing, and it's going to have handlers for those messages coming in. Effectively, I might have, you take damage, and the entity on the other side says, okay, I can take damage. I see this message, and I acknowledge it. Like, I know how to handle that message, so I'll process it. Then we also want to have over time ones that look at it and say, okay, it has been this long. So there needs to be when we do an action call here, we're going to iterate over those as well. So before we call an action, or after we do our action call, either way, what we can do then is we can iterate over a list of things that say operate on a timer. The basic one that we're going to implement first is a timeout. Effectively, after X seconds, this bullet goes away, kind of thing. After X seconds, this creature goes away, or this creature goes away if it is too far away from the player. So, for example, the player is moving very fast to the right, and this entity is falling behind on the left. Well, thank you, Alkaline. Thank you for the raid, and thank you, raiders, for joining. Okay, so we are going to add, it's not a behavior, now we're going to add interaction. So time-based. And collision-based. So this is, given a period of time, this interaction will occur. So we need a base interaction class. Will be another, partial abstract kind of thing. We might need to add some objects to it, but we can cover our bases with that with just a little bit of structure. So this is an interaction. Wait. Partial class interaction. So this is, this is our safety net for these overtime things. We will have a specific subclass that is a time interaction. And this only exists for the purposes of getting these baselines in there. Time interaction. Public. Abstract. Partial class. Extends interaction. There. For brevity. So then so we're going to do another delta. Okay, so a time interaction, its interact takes a float. Because time interactions are specific interactions. We're treating them all as interaction objects so that we can define them as one collection. There are interactions that you are going to get. But we are going to store them off specifically in the catalog. We're going to store them off as a generic in the catalog. It's just an interaction. Then when we're requesting them, we're going to request them as specific ones. And we even... I think this will muddy the waters. I don't think there's such a thing as a generic interaction. Yeah. I could have a very basic one that is just meant to be a house for things like Entity Manager. Things that they will potentially need, but there's nothing about a base interaction that necessarily needs that stuff. Like, in theory, behavior does not need these. The child classes, well, no, when it copies, it does need a catalog. But a base behavior has no need for an entity manager. Other behaviors might, but but they don't fundamentally need an entity manager. Just run this and make sure it doesn't explode as a result. Okay, yeah. So by default, when copying, you need a catalog to copy child objects. Yes. Okay. So there's nothing about the interactions that is shared currently. There's nothing about them that needs into any of the other services. A collision interaction. Abstract. What song is this? Let me check real quick here. This is called The Glass Slipper by Martin Clem. Oh, the one before? Okay. I'm actually not sure which one it was before because it plays in a random order. Might be Stepping on Glass by Nyanite there. I don't know if it was this one. Yeah, it was that one. Okay. Okay. No, we're not colliding with. Okay, we need a pair. We need a special class here. We have an interaction message here. Okay. When a collision interaction happens, we have a message that gets sent in. When a time-based interaction happens, it just does a timer. Call it interact in this case. Just for consistency here. So this one will take a delta in. Some of them are going to accrue a delta over time and look at it and say, is this past my limit? You know, after 3 seconds, do this thing kind of stuff. Gates behave that way. Gates can behave that way. Okay. Why did we do it this way? Delegate. Ah, here we go. This makes it so that we can define it cleanly instead of it being... I can't remember why we were having problems with enums, but this makes it clean enough. So this will be a spot that we can go into and have either strings, we can have any number of things in here for what type they are, and we can reference them accordingly. So an interaction message's content is going to be based entirely on which specific type it is. We'll get to that, though. We'll just have this structure in place. That's right, because it needs to be handled in a specific way. Add collision area. I'm trying to remember why we did it this way. Okay. Oh, it's so we don't have to convert it over. We can just constantly talk about it as that sort of type. And we could do type conversions on them this way, I think. Like I could change some of this stuff so that it has to be discrete. Um, Equal operators and what have you. Anyway, we'll probably make this a public read only. But we'd have to make sure that this gets set properly. Oh well, anyway. We have an interaction message. We have a time interaction. Uh, have float. Um, that's a double. Let's it's acting. Okay, it's a double that we need to be doing. The C# side of Godot uses a double as the delta type in all of its like basics shell processes, like process and physics process. But if you're communicating with Godot itself, like the other side of it, it doesn't operate with doubles. It only uses floats. So that is a error surface if you're not careful. By default, interact will always increment accumulated delta. Whether you do anything with accumulated delta or not doesn't matter, but almost all timer interactions should be doing something with accumulated delta. Like there should be an interval of some kind as well. Whether it is you saying like every second or it's 1 second until this goes off. Um, So what you would be doing is, on the regular, saying, is accumulated delta greater than interval? It will increment accumulated delta, and it will call... Yeah, I think interact should be a baseline. Because all timer-based ones should be looking at it and saying, how much time has passed? Is it greater than the interval? Yeah. Virtual. Okay. So every unit of time we pass in, like, this is the entity that is being checked, or this that you are associated with. This is how long has passed. We accumulate the delta. If then we call into the past. So this is the thing that normally would get overridden. Like the entirety of the behavior. Is greater than 0, and we don't care about any sort of part of the accumulation if we don't have an interval. So by default, what's going to happen is there's going to be a you're going to create a time interaction. You're going to set up its interval, and words and stuff. It will accumulate the delta over time, and then if it has an interval, then once that interval has been passed by the accumulated delta, we'll call interval passed. What it does with that is up to the child class. All right, so this should be catalogable. Okay, it is a catalogable time interaction, which means get the interval. Zero it out. Do the same thing here. Should it match the accumulated delta when we duplicate? For the time being, I'm going to say no. Okay, it's catalogable now. So now we can go into our catalog. Catalog has to have a get time interaction. And that. Let's see. Okay, standard catalog. That. Another get function here. Learn catalog. Time interaction. That won't work until we have an array here. Dictionary of string and time interaction. all time interactions. New dictionary time interactions. And then we need why lowercase to those. Well, I did like my initial programming learning, like formal learning, involved C. I really don't like trying to use name conventions as far as things like upper lowercase underscores, all of that kind of stuff, to denote how you should use something. I like the strong handling in object oriented that says if it's private, I don't have to tell you in the name that it's private. It won't let you use it if it's private. Okay, so we're going to jump to load entities here. Oh, that's why. No, no. All right, all right. Timer, and then call it lifespan. Hello, Dan. Language is that? I'm not familiar. Deep learning doesn't know. But hello nonetheless. All right, so we have our time interaction, it's timer lifespan. So then we go back into catalog, or we are going to go back into standard catalog where we load timer interactions. Now we're going to create so lifespan. It extends time interaction. All right. So a timer lifespan, if the interval passes, it goes away. The entity goes away. So then in our standard catalog, ten seconds. Log constants. Timer lifespan equal to timer lifespan. Okay, so we now have a time interaction. So then in an entity, in addition to behaviors in the like, we have a base behavior, we have behaviors. Public. Behavior, queues, and gates. So then when we initialize, okay. So now we can do things like for each on this. And we can also initialize it in the listing here. Then an entity act. Do base behavior act. Should be divided by 2 at this point. and then we get the next behavior group is what we're doing. So for this one, we're doing a for each. In interactions. Interaction. Dot. This entity and delta. All right. So now in our catalog, in our standard catalog, when we are loading entities, we're going to go down to our yarn ball here. And we are going to say entity time interactions and view. We just do add. If your group is a list, ultimately the same thing. At time interaction. Constants dot timer lifespan. Catalog constants dot timer lifespan. Yeah. Okay. Oh. Not present. Oh. Load the timer interactions. Let's check catalogable here. Oh. Let's see, entity. Okay. So in timer lifespan, got I'm going to have to check some of these because the copy constructor can be null. So if it's null, then we should just do the initialized stuff at the top. Yeah, I messed some of that up. Yeah. You need to account for this, though. Doesn't need to be a reference. I mean, it's supposed to be a reference, but it's going to be a reference because it's an object reference. It's not like an integer. Let's see. Behaviors are catalogable. Spawner is just a behavior. Movement is just a behavior. Oh, excuse me. Let's set that interval shorter. Standard catalog. And this is during load time interactions. We're going to set this to 3 seconds. Okay, that's not working, but, you know, hey, we're getting there. Oh, we need to copy the interactions. All right, quick break, and then we're back to it. And we're back. Okay, so then in the entity, when we're copying, we have the gates and behaviors. So for each interaction, in the dot time interactions dot enqueue. It's not going to be time interaction. It is going to be catalog dot copy. That time interaction. Okay. We're going to look at a couple of extra objects here that I think I may have messed up. Don't need initialize because this can be null. So check catalogable default, it's null, so there's not a constructor on it. Let's copy constructor with the null in there. Reason I'm checking for this is that I added a default constructor when that goes against part of the pattern that I was already using, is that this should be able to be null, and that means there's no default constructor. It's this constructor or bust, which is what we want. Behaviors are okay, gates should be okay. References. If copy is not equal null, nope. We have no defaults to do there. It's either we get it from the other gate or we set it to 0. Should be good with the gates. Let's check our null. If it does not equal null, else interval is 0. U, because that's covered. Okay, we're still not running those. Let's check. We're queuing copies of the time interaction. So then in timer lifespan. Okay, we're never hitting this. Interval is equal to 0. Okay, we're never getting a copy constructor. Create a new, we set its interval. So we're loading it in, and then we're loading entities. Entity time interactions. I'm going to step over that. One is timer lifespan, but it has none of the stuff in it. Oh, but why? It means our copy isn't happening. Cataloged is a thing. Create instance returned a timer lifespan, but with nothing. Let's try again. Okay, to instantiate as an interval of 3. So if I look at a time interaction, come in here, to copy is null. But that doesn't make sense because I did pass something in. Well, such is, debugging. Such is debugging. Step into here. We have a key. Source dictionary has an object in here which has an interval. Okay, to instantiate is a thing. And it is not null. This would have a problem if we pass in a null. There it is. Timer lifespan is not calling the base. Oops. There they go. We have now implemented a projectile lifespan. But they are not actually going away. All right, let's accelerate. Behaviors by default have an entity manager. Got an ad break happening on the Twitch side, so it gives me an opportunity to scrutinize a bit more. Hitting it by default. We're going to accelerate this. Let's speed it up a little faster. Standard inventory. We can make it go real fast. Okay, the entities aren't actually going away. Visually, they are. Okay, we have to call remove entity on it. Yeah. Through the entity manager. Ray's remove entity was telling all the visual stuff to remove it. 3, 9, 27 at once. 81 at once. Hello there, Papyrus. Welcome. Okay. This is the game we're working on. We are currently spawning 27 of the little balls at once. And they are moving in a spiral out from the center. Let's put in a gate here. So they're going to move out in a random direction and then start spiraling. And we'll do 3 at a time here. Okay, that's still too many. Let's let them die off a bit. Okay, we're gonna have to make sure that we don't spawn too many at once. Simultaneously, there's gonna have to be a bit of a delay on creating them all at the same time. We'll have to figure out some sort of limiter, because if I throw another one in here, it's going to start choking pretty quick. Right there. So this is just too many things entering and leaving existence at once. But if I drop it down to 27 entities being created at any given moment, then we seem to be okay. We'll have to keep an eye on this. This is potentially an issue as far as how this is handled. I could queue them such that only X are introduced at any given moment. So let's take a quick look at that. One second though. We're gonna make a quick commit. Then we're going to go into our entity manager, and currently our standard entity manager. Currently, when we go to add them, so right here in entities to add, we're going through the whole thing. Entities to add is a hash set to make sure Papyrus, it's not bad so much as there could be a limiting factor on this. Removal should be okay. Might not be, but we'll see. If there's at least one in it. Yeah, it's only 81 things entering or leaving existence at once is a bit of a threat surface as far as what we want to accomplish. Man, I don't know. The sprites that I'm using, and even this character model are derived from a narrative, a story that built up because of a Noida mod that I made and played with the community back in the day. In my older streams, you can see that. Shameless plug, watch my streams. We played it to death. We super played it to death. So we don't play it anymore. We just use first. Okay. IDs. Queue. I should make this a queue, but it ensures that we're not adding it multiple times. Well, I would like to make it a queue, but it's a hash set for a reason. Manadono there, we played it initially and we got a regular clear on the game. All the way to the bottom, beat Comey. We did some of the side objective kind of stuff. We aren't the type of player that wants to do like speed running or I'm not fond of the way that they do the hidden puzzles and whatnot in Noida. I feel that they're obscure and obtuse most of the time. So we got to the end, and it started to be, can we get to the end? We started adding, like, the community interaction stuff, add some mods, play some more stuff. And then we got tired of that, and we started to make our own. added our own random events, started adding new spells and whatnot. By the end, a great many of the perks were replaced with custom ones. We had a pile of special events that you could trigger with points, ways to create a character in the game for the community, that kind of stuff. A lot of it eventually devolved into the players trying to stop me from winning. And so orbital strikes like crazy, explosions, that kind of thing. My goal was to see how big a damage number I could create. I believe the biggest we ever got was in the quintillions. And we had the running joke of the victory condition being getting to minutes per frame instead of frames per second. There were streams where we were effectively sitting there watching a frozen screen to see if it would change fast enough to tell us that the game wasn't frozen. All right, this is going to be once per physics process step. We will add an entity. No, it don't like that. That don't work. So we might be getting a null out of this. No, it's a thing. Oh, we're not adding it to entities. Oops. Well, that'll stop it from doing anything. If it's not in the list, it never gets updated. But yeah, you can't see him very clearly, but the little robot in the center is a catbot. Okay, here's 3 at a time. Alright, the propagation here isn't doing anything. Oh, that's because we are absolutely limited. Okay. This may still not work. Up to 100 times a second will add things. This should be adding 781, 243 a second, but we're not getting there. A 1,000 times a second. Yeah, that'll do it. Just a limiter. Just a limiter on it so that it won't add too many at once was enough. Okay. We'll add a gate. That breaks it. This is adding too many things per unit time. So our spawn rate is too slow coming out of the player here. We're getting these little bursts going. How can we clean this up? Okay. More zeros. Where was that window? Pause. Not that we want to look at. Mostly the interop methods. Physics process of game, yep. Okay, so we're getting bogged down in the loop. Yeah. Cancel. Close everything. Okay. This is a choke point. we can't do too much of this. So we need a way to mitigate this cost. 254 things. It's not 254. It's 243 things at the same time is too many to create per frame. And to handle all the associated stuff. Now we could call deferred on it as a secondary function to essentially dequeue the ID, and like we remove it from the queue here, we dequeue the ID, and we say that we're going to add one. Okay, so we're going to switch back to this. T. These two things. Those up here. All deferred. Oof. It's the method. We need to throttle it, but the problem is that it's as if we ran out of. It's just another entity cap, effectively. Is at 30 times a second as far as physics update is concerned. We're just getting way too many of them. We can't call async. Even if I could get the terminology right for it, doing that is a problem. It would add thread safety to the issue here. Call deferred would essentially make it so that I have more physics frames to do this in. Process them. Build the templates. Okay, well, that's not going to help. Double accumulated. Okay, twice a second, we will emit entities here. And this is with us adding every single one we can. Okay. Ten times a second. 7, 81, 243. Okay. We have encountered or discovered another performance choke point. And that's generating entities over time. Threading this would be dangerous, or at least hard to do, or a hassle to do, let's say. Can we do it? Yes. But just doing it with threads is a problem, you know? Okay. How about go into the Godot project. Go to our physics settings, physics common settings. Let's leave that as is. Okay, so we're going at 60 physics frames per second. The movement is much smoother. I don't know that you can tell on the stream, though. Okay, 90 per second. 270 per second. Then 810 per second. 2,430 per second. Still our threshold. $810 things per second is pretty good. And they're still moving super fast during this. Like, we have plenty rendering. We have a lot of things going on. This is 9 are emitted in random directions, and then they split into 9 in spiral. 10 times a second. Which, plenty fast. For a single thing is the problem. But if we get much higher than that, it's still going to be a problem. Because we don't know how many of these weapons we want to have in place at a given time. I'd want at least like 3 of them. Okay, so let's drop back down to twice a second. That we're emitting anything, and see how high we can get. What else can we do? Okay. It's not nearly as many things being emitted. Those. Bunches of those. Okay, we're currently emitting 18 twice a second. These shouldn't be able to go there. There's a flaw in my logic if it goes there. 27. 2 times, twice is 4 times a second. Needs more. We do need to look at this. Greater than 0. Seven, 8, 9, 10. One full row. Six more. The testing gate there. I'll spiral just for the giggles. 6, 18, 54, 160 something. Okay. So we're going to have to think on this a little bit more. We do have lifespan in place. Let's recap. We got lifespan in place, so we have a new type of thing, a time-based interaction. So on an interval, do a thing. What that thing is pretty flexible, so we'll be able to run with it. Now, we also got all of our pseudo-dependency injection ready to roll. We have a services object that stuff can just reach out and grab, essentially. Well, references too. Ow, my spine. Ah. I have suddenly been apparently sitting wrong. There we go. No, it's still there. Ow. So we have our pseudo-dependency injection in place. Things can reach out and grab what they need to function. So we just need to do an initialization on it when the program starts to load up all of the item data. And then and any other relevant things like save files, all of that would be preloaded and not change over the course of the run. Aside from like being recorded in a state, being written to file, that kind of thing. But we wouldn't be reloading them with any frequency. Then the game state stuff gets set up when the game starts. So we're all set there. What we're running into now is a entities created all at once kind of problem. We need to figure out a way to spread that out without relying on the rendering or physics ticks to cover it, because those become the better your computer performs, the faster it goes kind of thing. And we can still only go so fast as far as projectile generation before it creates problems where you don't emit a projectile because there are splits happening out in the world. That can't happen. So we can't have some sort of like throttle on it that says only so many per frame. And we can't rely on the idea that through some fluke of logic, they can't generate that many projectiles. I don't want the game to grind to a halt so easily. We are dealing with border cases, but this is when I want to deal with a border case, not when I'm effectively in late beta and find out, oh no, I have to go in and gut a whole bunch of stuff to prevent a fatal bug or something that kills the frame rate on the reg. So when next we stream, hopefully tomorrow, we're going to pick up on this performance hitch here. We need to get it to where this is smooth to a limit. There's only so much we can do before it goes too far too fast. And finding that and dealing with it gracefully is what we'll need to do. So, if you like what you saw and would like to see more, remember to like, follow, subscribe, push all those good buttons. It helps the channel grow. You can also do that through subscriptions, memberships, Patreon, all of that good stuff. There are links to that in my LinkTree. With all that said, I hope the rest of your day is good, and I'll see you next time.